Lesson 28 is transformations of radical functions, and we've talked about this in a previous lesson in lesson 26, but this one is kind of more focused on identifying transformations from a graph and writing functions from them. So 28.1 is translations of radical functions. So the kind of like general formula that we can use just when translations are involved. And just as a review, translations are a type of transformation that just shift the graph left or right or up or down. It doesn't change like the orientation or like kind of like the shape of the graph at all. It just moves it side to side. So that formula is f of x equals the square root of x minus h plus k. And it doesn't have to be a square root. It can be any type of radical. But it's important to know that h tells you how far you go left or right. So if h is positive, you would go right. If h is negative, you would go left, since that's like the negative direction in terms of left or right. And then k tells you how far you would go up or down. And then I know we've talked about this throughout the year, but it's important to know like there's a minus, or it's x minus in the formula. So when you're looking at a function or writing a function, it's kind of like h is opposite of what it looks like it should be. So if you saw like x minus 4 inside the radical, it would be like going to the right 4 because h would be positive 4, versus if you saw x plus 4, that would be left 4. That negative that's in the formula, or that minus that's in the formula, kind of like makes h the opposite of what it looks like it is. Okay, so example 1, f of x is equal to the square root of x. Find f prime of x based on the translation in the graph. So f of x, like the starting one, is the green one, and then the f prime of x is kind of like the reddish one. So you can see it's definitely moving upward. We're just dealing with translations right now, so I'm not going to worry about like if I think that the points are like stretching or anything like that, which they aren't. But you just see it's moving up, so to figure out how far up it's moving, we just need to kind of pick like one key point and see the change in that point. So I think it's best to just like start with 0, 0 and see what that point moves to, and it's moving up here to 0, 3. So it's moving up 3 units, and that would mean that k is 3. So if k is 3, then I just need to kind of add a 3 into the function where k would typically be, and you can see that the k is added outside of the radical. It's like added kind of like, usually it's like at the end of the function altogether. It's just added as a constant. So if I wanted to write f prime of x, I would still start with the original function f of x, which is just the square root of x in this case. It's just the parent function. But if I wanted to move it up 3, I would have to add 3 after or outside the radical just as a constant, and that would move it up 3. So my final function for f prime of x would be f prime of x is equal to the square root of x plus 3. And then example 2, f of x equals the cubed root of x. Find f prime of x based on the translation. So same set of directions, just like kind of a new starting graph. So this one is a cubic function. You can see the graph looks different, and then as well it's f of x equals the cubed root of x. So if we look at the original one, the green one, we want to figure out how far it's shifting. We can see it's shifting like kind of to the left, but if we want to figure out how far, we need to pick a kind of point to focus in on. I'm going to focus on 0, 0 again. That point shifts over here to what looks like negative 4, 0. So it's shifting 4 to the left. So I'm going to say negative 4 since it's going left. So h, in this case, since we're going like left or right, h is negative 4. So that would mean that we would take our like h equals negative 4, and we'd have to kind of embed that into the function where the h would go. So it would be f prime of x is equal to the square root, or sorry, the cubed root of x. And then it's usually x minus h inside that radical when we have a horizontal translation. But since h is negative 4, I'm going to take that h out and replace it with negative 4. And then we would just want to simplify it all the way, so we would never leave like the double negative there. We would go ahead and change that double negative to a positive. So it'd be f prime of x is equal to the cubed root of x minus negative 4, so x plus 4. So f prime of x is equal to the cubed root of x plus 4, which means it's like we took the cubed root of x and we shifted it left 4. For example 3, g of x is equal to the cubed root of x minus 2 minus 3. Find g prime of x based on the translations in the graph. It's important to note that like for this function, we don't really start with the parent function, and that's okay. We have that kind of like minus 2 and minus 3 that are already in there, and we can just go ahead and make kind of modifications and changes to those numbers to get our new function g prime of x. So in order to figure out what translations are happening, same kind of like approach as before, where we focus in on kind of like a key point. So if I look at g of x, I'm going to focus in on this point right here at 2, negative 3. That's the point that like for the parent function is usually at 0, 0, that like kind of little curve where it like flattens out in the middle. And then that same point is over here at 5, 5. And then we just want to kind of count the change or figure out what change is happening to go from that point in g of x to g prime of x. And it looks like we're going from negative 3 on y up to a positive 5. So we're going up 8. And then we're going from negative 2 on the x over to 5 on the x. So we're going over 3 units. And you don't have to like count it necessarily that way. Like you could literally just count the units, like how far up we're going. Like we're going 1, 2, 3, 4, 5, 6, 7, 8, and then over 1, 2, 3 to the right to get to that new point. So if we're going up 8, that would mean that k is 8, and then we're going right 3, so h would be 3. So I'm going to show you kind of two approaches that you could take to figuring out what g prime of x would be. So I'm going to go ahead and I'm just going to rewrite the function. So g of x is equal to the cubed root of x minus 2 minus 3, and then we can just take those values that we got for h and for k and kind of put them in the right location. So like I know typically inside the radical it's like x minus h, so I'm going to go ahead and just take my h and write that inside. So it'll be g prime of x is equal to the cubed root of x minus, and you could put it before or after the 2. I'm going to put it after the 2 since the 2 is already there. So I'm going to put minus 3 at the end, and then outside, let me extend that radical a little bit. Outside of the radical, there was already that minus 3 there, and then k is 8, so I just need to add an 8 after it. And then now I can go ahead and simplify, but those changes are just getting kind of, I guess, brought in addition to the values that were already in the function. So g prime of x is equal to the cubed root of x, and then negative 2 minus 3 is negative 5, and then negative 3 plus 8 is 5. So plus 5 outside the radical. So g of x is equal to the cubed root of x minus 5 plus 5. A different way that you can do that, if that was like a little bit confusing, like kind of including the like negative 3 and the plus 8 there, is to think of it more in terms of like the general function notation. So what I mean by that is, let's see, let me try to like kind of separate this. Okay, so that general function formula in terms of transformations is like f of x minus h plus k. So f of x minus h plus k, well, if h is 3, I'm going to put that in for h. It'll be f of x minus 3. And then k was 8, so I'm going to put that in there. So we put 3 in for h and 8 in for k. So now what that means in terms of like how we change the function is, hold on, let me rewrite it one more time. I'm just going to take this one and copy it down. And this kind of problem has g of x, but f of x, they're all kind of like interchangeable. So what that means is that if you have like a change to the input of the function, which is like what's inside the parentheses here, how there's like an x minus 3 inside the parentheses, that means everywhere there's an x in the function, you replace it with x minus 3. And then this like plus k at the end of the function gets added to the end of your function, whatever your function is. So it could be as simple or as complex as possible. You would just slap a plus 8 onto the end. So then g prime of x would be the cubed root of, I have to replace x with x minus 3. So x minus 3. And then everything else in the function or inside the radical would stay the same. So I'd bring down the minus 2, and then I would have the minus 3 outside the radical. And then to go up 8, I would have to add that 8 to the very end of the function. And then now I would simplify. So g prime of x is equal to the cubed root of, I would go ahead and like combine these two together. So x, and then negative 3 minus 2 is negative 5. And then over here, negative 3 plus 8 is a positive 5. So plus 5 out here. So you end up getting the same answer, regardless of if you kind of start with like the radical formula that has translations in there, or just that general function formula. I think we learned about it in unit 4, if you wanted to go back and kind of look through those notes one more time. Okay, so either way, g of x equals the cubed root of x minus 5 plus 5. Okay, so 28.2 is dilations of radical functions. So the formula for radicals that involve dilations, which could be a vertical stretch or compression or a horizontal stretch or compression, that formula is f of x equals a times the square root of 1 over bx. So usually won't see a vertical and a horizontal in the same function, but this is where they would kind of be placed. So a would be out in front of the radical, and that is a vertical dilation. If the absolute value of a is greater than 1, it would be a stretch. If it's between 0 and 1, it would be a compression. We use absolute value because if it's a negative a, that would involve some sort of reflection, and we'll talk about that later on in this section. And then for b, it's actually 1 over b, or the reciprocal of b, that goes into the function. And if b itself, so like if, let's say inside the radical you have a 1/2, that would mean that b is just 2. It's just the reciprocal of what you see in the problem. It would always be inside the radical, it would be multiplied by x. So that would give us a horizontal dilation. If b, or the absolute value of b, is greater than 1, it would be a stretch. If it's between 0 and 1, like, I don't know, 0.3 or something like that, it would be a compression. And then if it's negative, it would end up being a reflection as well, just a different type. And then same thing, we'll talk about the reflection version kind of later on in this section. Okay, so example 1, f of x equals the square root of x plus 5 minus 6. Find f prime of x based on the dilation. So if you're trying to figure out what a dilation is, you kind of have to look for a pattern or like a scale factor between the points. So if I look at, like, say this point right here on f of x, it becomes this point right here on f prime of x. So between those 2 points, the x coordinates are staying the same and the y coordinates are changing. They're going from, in this case, negative 6 to negative 18. So they're being multiplied by 3. And then if I look at another set of points, negative 1, negative 4 to negative 1, 12, same thing. The x coordinate is staying the same. The y coordinate is being multiplied by 3. And that pattern continues on all the way throughout the function. So if it's the y coordinate that's changing, like we go negative 6 to negative 18, negative 4 to negative 12, it's a vertical stretch or compression. In this case, if f of x is the green one, that's where we're starting, the red one is getting pulled away from the x-axis, so it would be a vertical stretch. Another way of telling that is whatever you're multiplying like each point by, like what the scale factor is, in this case it's 3, that is your a value. So that's telling you if it's a stretch or a compression. 3 is greater than 1, so it would be a stretch. So change in, I'm going to add this, change in the y coordinate is it's a vertical dilation in general, and then it could be a stretch or compression depending on what the change is. Okay, so now I just have to take that scale factor 3, that's going to be my A. So A is equal to 3. I just got to use this kind of like form and know that, okay, if A is 3, that means I multiply 3 by the original function. So I'm going to write this a little bit differently than I did the previous ones. I'll kind of add an additional step just to see the structure. So f prime of x is going to be equal to 3, the scale factor, multiplied by the original function f of x, and it is getting multiplied in front of the function, not like inside here. That would be for a horizontal dilation. That'll be the next example. So what that means now is that I go ahead and I take the actual function for f of x and I swap it into f of x into this kind of like template that I have. So it'll be f prime of x is equal to 3, that's my A, my scale factor, and then times, and because f of x kind of has different parts to it, I do need to put it in parentheses, so it'd be times the square root of x plus 5, and then minus 6, and then now I just need to go ahead and simplify and make sure I distribute in and everything like that, and then I'll be done. So f prime of x is equal to 3 times the radical. I can't multiply the 3 inside the radical, so it just becomes like 3 times x plus 5. And then 3 times the negative 6. That's why it's important to use parentheses, because it's easy to forget that. So 3 times negative 6 is negative 18. And then now it's as simplified as we can get. So f prime of x is equal to 3 times the square root of x plus 5 minus 18. Okay, so biggest thing from this example, you have to look at what coordinate of the point is changing, the x or the y. If the y coordinate is changing, it's a vertical dilation. And what it's changing by, like what you're having to multiply, that's A. Okay, example 2, f of x equals the cubed root of x minus 3 plus 5. Find f prime of x based on the dilation. So same approach, we're going to look at the points and see how they change. So let's see, this point, negative 5, 3 becomes the point negative 23, and then this point 12, 5, oh wait, no, sorry, I've like kind of mixed my, wow, that's a trip. Okay, sorry, this point this point 3, 5 becomes 12, 5. I'm just going to start that over because I kind of butchered that. Okay, so we're starting with the green function f of x. So this point, negative 5, 3, pulls outward and becomes negative 23. And then this point, 3, 5, pulls outward like towards the right and becomes 12, 5. So if we look at what coordinates are changing in this case, it's the x coordinate. So to go from negative 5 to negative 20, I'm multiplying by 4. And then to go from 3 to 12, I'm multiplying by 4 as well. But I'm changing the x coordinate. So if you have a change in the x coordinate, it's going to be a horizontal dilation, and depending on what that scale factor is, in this case it's 4, that would tell you if it's a stretch or a compression. So if you have a change in the x coordinate, it's a horizontal dilation in general, but because our scale factor is 4, that's going to be our B value, because we use B for like the horizontal stretch or compression. Because that's greater than 1, then it's a horizontal stretch. You can also tell by looking at like, picture like if you were to be able to grab like the ends of the green function and pull it outward, it would stretch it outward to get to the red function. So it's pulling and stretching it further away from the x-axis. Okay, so our B is 4. So I'm gonna scroll back up really quick just to kind of point something out. It's just important to know like what the different variables represent typically, because they stay consistent like throughout math. So A is for vertical dilation, B is for horizontal dilation, so that'll stay consistent like throughout the year. Okay, so now I want to kind of write that like kind of template version of the formula before we go ahead and start working with like actual f of x. So if we have a horizontal dilation, f prime of x is going to be equal to f of 1 over b x. And we just figured out that b is 4. So I'm going to take b out and put 4 in. So notice I didn't make it like 4x because b was 4, but it's 1 over b. It's always the reciprocal of b that actually goes into the function. So like if b was 1/2, you would put 2 in the function because that's the reciprocal of 1/2. And then now what this means is that anywhere there's an x in the function, we're going to replace it with the 1/4 x. So I'm going to rewrite the kind of like original function right now, and then I'm going to end up erasing some of it. So if you wanted to wait till I finished, that would be okay too. So f prime of x, I'm going to take the f of x and put it right here. So cubed root of x minus 3 plus 5. But since I have to incorporate that horizontal stretch, this like kind of format right here where there's a change happening to the x inside the parentheses means that you make that change to the x in the function. So we would replace any x in the function, in this case there's just the 1, with 1/4 x. So I'm just going to go ahead and erase that x and put a 1/4 x in there for it. So f prime of x is equal to the cubed root of 1/4 x minus 3 plus 5, and there's nothing to simplify there because I don't have anything to like multiply in. That change got made just to the input, just to the x, so it's fully simplified. Okay, so biggest thing I can stress from when there's either a horizontal dilation or a horizontal translation is that you end up having like kind of a change happening to the input of the function, like to the x inside the parentheses in function notation. And that means that you just make that change directly to the x in the actual problem. Okay, so moving down to vertical and horizontal reflection. So vertical reflections happen by, so they're a reflection over the x-axis, which basically means that you make the y values the opposite like kind of sign. So you can even see that in example 3. Like 6/5 became 6-5, and 14/7 became 14-7. So what that means, if we're negating the y's, we're negating the output, so we're basically negating the entire value of the function. So it's negative f of x. And then for horizontal reflections, and you can kind of see it in example 4, the x values are what's changing. So like we're going from 2,3 to negative 2,3, 14/7 to negative 14/7, and so on. So the x value is all that's changing there. So we're negating the x's, we're negating the input, which is why only the x becomes negative. Because we know that like function like f of x is the same thing as y. So this is basically like saying negative y, the y's become negative, and this is saying negative x, the x's become negative. Or just the opposite of what they were. So like positives would become negatives and negatives would become positives. Okay, so on to the actual problems. Example 3. F of x equals the cubed root of x minus 6 plus 5 is reflected vertically to get f prime of x. Write a rule for f prime of x. So f prime of x is going to be equal to negative f of x if it's reflected vertically. So since f of x is cubed root of x minus 6 plus 5, I can take that and put it here. I will have to put it in parentheses though because we have that separate term outside the radical. So it'd be f prime of x is equal to negative, and then the cubed root of x minus 6 plus 5. And then I have to distribute that negative in, making sure that it goes to the plus 5. It goes to every term from the function. So f of x is equal to negative, it goes to the radical. So negative cubed root of x minus 6. And then it gets distributed to the 5 as well. So negative times plus 5 or positive 5 would turn it into a negative 5. So f prime of x is equal to negative cubed root of x minus 6 minus 5. It's important to realize that like if you're multiplying in something in, whether it's a number or negative, it doesn't go inside the radical. It just becomes like a kind of like a coefficient, a number in front of the radical. And then for example 4, f of x is equal to the cubed root of x minus 6 plus 5 is reflected horizontally. To get f prime of x, write a rule for f prime of x. So f prime of x is a horizontal translation. So horizontal translation is f of negative x. So f of negative x means that, we're going to take f of x, and wherever there's an x in it, we're going to replace it with negative x because the change is just happening inside the parentheses. So f prime of x is equal to I can actually start with the function now. The cubed root of, so there was an x right here to start. It's going to get replaced with negative x. And then the rest of it, the function stays the same. So minus 6, that doesn't change at all. And then the plus 5, that doesn't change at all. So the only thing that changes is the x. It gets replaced with negative x. So altogether, f prime of x is equal to the cubed root of negative x minus 6 plus 5. 28.3 is transformation rules of radical functions. This kind of just combines multiple transformations into one, just kind of an additional version of the problems that we've pretty much been doing, but we may see more than one transformation together. I know you've kind of seen this formula before, but just so you have it here as well. This is the formula that has all the different kind of transformations embedded into it. So f of x equals a times the square root of 1 over b x minus h plus k. So a is our vertical dilation. It can also be a reflection over the x-axis. B is our horizontal dilation. H is our horizontal translation. So if we're shifting left, right, up, or down. And then K is our vertical translation. So if we're shifting up or down. And then kind of for more details from those letters, variables, they were given throughout these notes. So H and K, that was from the first half of the notes, 28.1. And then A and B were from that second part, 28.2. Okay, so example 1, if f of x is equal to the cubed root of x minus 2 minus 5, write a rule for f prime of x. So there's a couple different transformations happening here. You can see that there's a reflection, a vertical reflection, because the graph is flipping and it's going a different direction. So if f of x is where we're starting, you can see that's trending up and to the right versus f prime of x is going down and to the right. So instead of going upward, it's going downward, it's flipping. It flipped horizontal, or it flipped vertically. You can also tell that by kind of seeing that the points are changing from negatives to positives, but that's not always an indicator of a reflection, just because there could also be certain translations that have that same effect. We also have to kind of think about, are we shifting each point up by a consistent amount, or are we multiplying each point by a scale factor? So you can kind of see that these points are not changing, or we're not shifting points a specific amount to get to the next one. So you could see that this gap is around 4-ish. This gap gets bigger, this gap gets bigger. So I can't just say I'm moving all the points up. It's not a translation. It's not happening at the same rate for each point. So it must be some sort of dilation. So now if we start thinking about a dilation, we have to look at what coordinate of the point is changing. So we're going from -6, -7 to -6, 7/5, to -5 to 2, 1, and then 10, -3 to 10, 3/5. So the x coordinates aren't changing, the y coordinates are. So we have to figure out, what am I multiplying each of my y coordinates by to get to f prime of x? I think it's easier to focus on those middle points, so 2, 1 and 2, -5, and it's easy to be oh, well, I have to multiply by 1 by -5 to get to -5, but we aren't starting with 2, 1. 2, 1's the final product, it's f prime of x. So we have to remember that we're starting with f of x and we're going to f prime of x. So we're starting with -5 and we're going to 1. So if we're going, you can still use that like 1 times -5 would get me to -5 to help you. You just have to think, okay, what's the opposite of that? Well, the opposite of multiplying -5 is like dividing by -5, but in terms of scale factor, we don't think of division. So instead of dividing by -5, it's the same thing as multiplying by the reciprocal, so multiplying by -1/5. And then we'll take that, we'll just kind of check it with the rest of the points. So our scale factor we think is -1/5. So like if I take -7, and I multiply it by -1/5, that's definitely going to get me to a positive 7/5, because a negative times a negative turn positive. 7 times a fifth would be 7/5. And then -3 times -1/5. Negative times negative would be positive, and then 3 times a fifth would be 3/5. So that's our scale factor. That's our A is -1/5. And because it's that, like, it's kind of like a combo, but it's pretty much all in one, because the negative is the reflection over the x-axis. And then the 1/5 is the vertical compression. So it is two like types of transformations, but we get to kind of put them in all in one step essentially. So I'm going to use that kind of like function formula to start to kind of create a template for us. So f prime of x, if we want f prime of x to be a reflection and a vertical compression of 1/5, it'd be -1/5 times f of x. So now I can just take f of x, which is the cubed root of x minus 2 minus 5, and put that in here. So it'd be f of x is equal to -1/5, and then because f of x has that like kind of different, like the -5 outside of the radical, I do need to use parentheses again. So cubed root of x minus 2 and then -5 outside the parentheses. So f prime of x is equal to -1/5 times the cubed root of x minus 2 minus 5. And then if you can simplify, you need to. So we would need to go ahead and just distribute in that -1/5. So f prime of x is equal to -1/5 times the radical. It doesn't get multiplied in, it just stays out in front. So -1/5 times the cubed root of x minus 2. And then -1/5 times -5. A negative times a negative would be positive. And then a fifth of 5 is 1. So 1/5 times 5 would be 1. So f prime of x is equal to -1/5 times the cubed root of x minus 2 plus 1.